So hello, we're going to make a screen video about using Git and GitHub. It's important to distinguish these two things. Git is a tool for version control, for storing multiple versions of files and being able to branch them, work on separate branches, and to be able to get back to earlier versions should something go wrong with new work you've done. GitHub, on the other hand, is a place for storing Git repositories. There are other such places, and you can store them simply inside your own organization as well. What we're going to do is walk through what I think are the basic steps of using Git. Other people may have different basic steps. Git does support different types of workflow. I'm going to show you the workflow I recommend and talk a little bit about some other ways you might work. What we have here is I made a demonstration repository. It doesn't really have anything in it right now to speak of. Conflict.txt we're going to get to later. We're going to see what that is. But over here we've got a button we can push to get the URL we need to clone this repository. So I'm going to copy that. You need to decide where you want the repository to live. I happen to have a folder called Git projects, and we're going to type git clone, paste in the project we're cloning, and now we're going to go in there and see what we've got. So you can see the repository had a README file in conflict.txt. We now have the same two things. See, there's a little bit more. In particular, we've got .git. .git holds the actual repository. In Unix, when you start a file name with a dot, that makes it a hidden file. So when we do an ordinary ls, you won't see it. When we do ls-a, we see it, and now we can look and see what's inside there. So these are the components of the repository. We are not going to pry into the inner details of what's in the repository in this video because we're just trying to get a working knowledge of how to use Git, not become Git engineers. So the first thing we'll do is create a new file and look at how to add that. I have a little macro there for quickly creating a HTML page, and we are going to just give it a little bit of content of how to use Git. All right, we write the file, and now we're going to do git add. This must be done the first time you want to put a file in the repository. There are different workflows people do here. The one I use is I just add the file the first time, and then typically I commit. Git commit is another command. What this does is it puts the current work we've done on a file into the repository. Right now we're in a working directory, and the work we do on something does not automatically go into the repository. We have to commit the work. That means we're okay with what we've done. We want it to show up in the repository, and we get to give a message. The -m is the message that goes with the commit. This is important, especially if you're working on a team. You want to let your teammates know what you're up to when you're editing a file. And here it's nothing. We're not doing anything serious, so we're going to say git commit just a demo. But it doesn't like us using the exclamation mark. The shell interpreted that. So let's rewind and try that again. Okay, now we've got it committed. And now we're going to push our changes up to the origin. The origin repo is the repo we see over here on GitHub. It's the origin because that's where we clone from. And we're going to push the master branch. Git does support different branches of development, and we'll talk about that in a few minutes. So we have now pushed that index file. We're now going to use another feature of GitHub, and we are going to come here and say, let's serve this as a web page. And we're going to say, use the master branch as the source of the website. We save this, and this will now be published. This can take up to 10 minutes to show up. Often it's faster than that. So let's see if we've got it already. If we do, it will serve the index page as the default, and here we have it, Git demo, a demo of how to use Git. So we already have put up a website based on our repository. This is a great way to document your repository. It's to my mind, it's foolish to have a separate set of documents somewhere else other than the repo. Just make the repo document itself. All right. If someone has been changing something, let's go back to the repository, and we're going to be trying to create a conflict here. Hopefully, I can pull this off okay. Here are some new changes. Okay, if we look at what we have conflict.txt. This file will have a conflict. We've just put in some new text, and now we want to commit the changes. This isn't recommended to be editing these files right on GitHub, but in this case, I'm trying to create a conflict between these two versions. The next Git command we're going to look at is to pull, and that gets us the latest changes. We're pulling from the origin again. That's our GitHub repository, and we're pulling the master branch, and we got one change file. And now if we look at that file, we've got here, you see we have the new text we put in. Now if we want to get rid of something, we're going to put in a nonsense file. We're going to commit it. Sorry. And we'll just note that it's just garbage, and now we'll push it. And we now look at our repo. We've got garbage.txt. If we need to get rid of this, it's important. Well, let's move it and then get rid of it. So first we'll do this, git move garbage to, we'll put the garbage in the trash can. And now we can do commit again. Besides committing a particular file, we can also say we want all our changes, everything that we've worked on during that session. -A is for all. And we're going to say put garbage in trash. And we're going to push that. Scrolling back to my history. By using git move, it now shows up on GitHub as trashcan.txt. If we had merely done the Unix command move or typed in a window over the file name and renamed it, Git wouldn't know we had done that. So this, after all, is a meaningless file, so why don't we just get rid of it? We run git rm, and now we want to commit again, and we can say this time we took out the trash. These, of course, are kind of silly commit messages because we're not doing real work, we're just doing a demo. But when you're doing real work, you want to say something like, I updated the screen to display the student's social security number so people know what you've been up to. We do a push and we look at GitHub and the trash is gone. We also can check how we're doing, what the state of our repo is. We can run git status. Here we see that. We're on the master branch. The branch is up to date with origin master, and there's no outstanding work. Let's say we do a little work. Let's try to make a conflict in this conflict file. We'll try this, creating a conflict, and right quit. Now if we do git status, we see that we have a modified file. So git status will show us that we've got work that has not been committed. So it says changes not staged for commit. What we're going to do now is edit the file over here, and this file will, we have to click on edit, sorry. This file will now have an unfortunate conflict with these new changes. And I am hoping that Git will not be able to automatically resolve this conflict. Sometimes Git can, but here I've edited the same line. Generally that means that Git is not going to be able to resolve the conflict itself. So let's commit our changes here, and we're going to say creating a problem as our commit message. And now I'm going to try to push the changes. Okay. So we get a message saying that the remote contains work that I don't have locally. That's what we did that on purpose. We expected that. So let's try to pull. So let's get that work that we don't have locally. We do a pull. There's merge conflicts, right? So as I hoped, Git could not resolve my conflict here because I was editing the same line in two different places, and Git doesn't know what to do. Often if one person has edited line 1 and another person has edited line 10, Git can automatically merge the changes, and that's lovely, but there are going to be times when it can't. So let's look at what Git does when we have this situation. What we see here is Git's attempt to show us the two different versions of files. It's a successful attempt. This is all fine. So the head, which is my version, has the text creating a conflict. The version online, as you see here, has this file will now have an unfortunate conflict. And Git wants us to pick between them. It marks one version with this notation here, head. Here comes the second version, and the hash of what commit that was to the repo. So what we have to do is pick one or the other. So let's pick the online version. No, I take that back. Let's pick my version. so we can make the online version different. We added it. Unconflicting our conflict, and git push origin master. Now the push goes through fine, and if we refresh the file here, we see the text that I added in locally in this window. All right, Git also allows branching, and we can create a new branch with the git branch command. Following Jez Humble's recommendation on continuous integration, I don't recommend branching in general except when absolutely necessary, because what branching does is create an integration problem down the road. And the longer the branches are separate, the worse the integration problem tends to be. So we're actually not going to create a branch right now. If you've created a branch, you use the git merge command, and this will be the branch name we just created. We would have done git branch branch1, so git merge branch1 will merge that back into master. So if you're using branching, you can branch and merge branches back in using this. The other thing we should know about conflicts is, let's create this conflict again. I'll just show you one other way to resolve it. So I'm going to edit again here, and we'll pick this version. And we'll save this file. Let's edit it again here. And creating a conflict, and we'll pick other version. So we can do git status again, and we'll see that we again have a modified conflict.txt that's not checked in. Let's commit it. Creating more problems. Now we try to push, and we get the same message. Updates were rejected because the remote contains work we don't have locally. That's what we did over here. We deliberately created this. Now we'll try a pull. And it says, there's merge conflicts. What we can do is we can decide that we want the their version of the file. So we're going to check out theirs conflict.txt, and now we're going to do a commit. So what this did, another option there is instead of theirs, you can do ours. So this said we want their version rather than our version. If we had used git checkout ours, that would say, please pick our version, not theirs. And then we can go ahead and use GitHub version. Again, these are silly commit messages. We're not on a real project here. And now we're going to push. And the push now will work. We've resolved the conflict, and we'll see we still have the same version, because between our version here and their version over there, we said git check out theirs. All right, I want to touch briefly on the topic of submodules, mostly so you know what these are. We don't need to go too deeply into this because creating them and manipulating them is a somewhat advanced topic, but I do want to go quickly through what you may have to do yourself if you're working on a project with a submodule. We're going to go to my repositories. We have a utils submodule that has utility programs that are shared between lots of projects. Things for creating web pages, converting Django pages to HTML and the other direction, checking HTML checker checks for matching tags and so forth. So this utils directory is shared between many projects, and Git has a facility called submodules that allows us to do this, and we are going to add it. We want the same URL we used to clone it. We use that for the add, so we're going to do git submodule add. I came here and grabbed this the same way I did the other URL. Now the first time we do this, the person who does this will have the full submodule with all the files. We're going to point out something tricky about this for people who aren't the original adder of the submodule. We're going to do a commit again, added utils submodule, and we're going to push. Now let's go back to our DevOps demo and have a look. And we now see that there's a folder, but it's not an ordinary folder. Well, let me create something in a folder for you. Touch demo folder / sample.txt. We have to make the directory first. And now we can touch the file. We're going to add demo folder sample. We're going to, I'm just going to do a commit of all here to save a little time. Added file in folder. Git push origin master. Okay, just so we have a folder to compare this to. I realized trying to compare it to a folder that's not there is a little difficult. Here's an ordinary folder, or directory as we old timers might call it, and we have the sample.txt here, and we see we're still in the DevOps demo repository. Utils looks different. It's utils at something, another hash, and when we click on that, we've actually left the DevOps demo repository. You see up here, we're now in the utils repository itself. So this utils folder is not actually in the DevOps demo repository. The only thing that's in the DevOps demo repository is a link to this folder. This can create tricky situations. The first thing to know is that if you clone this DevOps demo repository at home, and I do advise you to do this at home to follow along, what you're going to find is that you're not going to have any contents in the repository. You're going to need to run two commands, git submodule init. They're not doing anything for me because my submodules are updated, and then git submodule update, and that will fill your submodule with the files that I got as the creator of the submodule. Unfortunately, submodules, the implementation seems to leave something to be desired in Git, and the connection. So we look here. What we have here is just a link from DevOps demo to utils. This link seems to be a little bit fragile and break easily. We have documentation online on our course website about what to do when this happens. In general, the thing to do is delete the submodule, which itself is a somewhat lengthy process, 5 or 6 steps, and then re-add it. Because the submodule is not actually part of the repository, all we have is a link. All we're doing when we delete it from the project is we're breaking the link. The utils will still be there. You're not going to damage anyone else's ability to use them. You're just taking the submodule out of the project you're in, and then you re-add it with the steps I did here, and it'll be back. And that generally clears up any problems you have if you start getting something like messages about the submodule being out of sync with its source module. Okay, that's today's Git lesson. Hopefully this gives you the basics of what you need to work day to day on one of our projects with Git. All right, take care.